Good morning, everybody. This is a live severe weather update, an emergency update as the tornado threat is increasing across a large swath of Iowa. I think that the threat is greatest across northwest Iowa and across the northern portion of Iowa. Focus in on that surface low track and just how deep that surface low gets, diving all the way down to about 993, 994 millibars. You may remember from a couple of days ago, just the GFS model was showing that potential for the deeper surface low. Meanwhile, the European and the NAM models were showing a flatter trough ejection, a weaker surface low. The short range models have definitely gravitated toward the original GFS run that showed that stronger surface low. See the surface low passing right over Omaha and then to the north of Des Moines. That's where the greatest wind shear is going to be. That's right along the nose of the low-level jet. Here is that low-level jet. This is by the 3-kilometer NAM, and you definitely want to focus on the nose of that low-level jet and how tight that gradient is to the Pacific front / dry line that ejects on the south side of that surface low. And right at the nose of that low-level jet into northwestern Iowa is where that greatest tornado threat is going to be anticipated. Here is that 3-kilometer NAM loop showing you the surface low, also down to about 994. You can see it jumps up and down a little bit with those convective feedbacks within that convective arc. This is going to be a relatively fast-moving arc of supercells, as would be expected up here in the Corn Belt during the early season. Dew points are going to be in the 50s. Temperatures probably about 60. It's likely going to feel just a little bit cold out ahead of this arc of storms, but it's a lot colder aloft, just above the ground, and those are the basics of instability, or when you get relatively cold air, cold, dry air aloft, over top that heat and moisture at the low levels. This is the EHI, or the Energy Helicity Index. This is a composite index that factors in surface space CAPE, which is instability, and also low-level wind shear in the 0 to 1 kilometer layer, the lowest kilometer right tight to the ground. And basically the bright colors show where there's a more favorable co-location of that low-level shear with the instability. You definitely want to target the northern edge of this blob because that's going to be right along the surface low track where that wind shear is maximized. And it certainly looks like that tornado threat could be enhanced from Des Moines off to the north to the Minnesota border, eventually stretching into southeastern Minnesota as well, and southwestern Wisconsin. Northern Illinois even could get in on that severe weather threat later this evening. Looks like that's going to continue after overnight. That's about 10-11 p.m. when that favorable shear instability environment arrives across northern Illinois and into southwestern Wisconsin. It'll probably be a line, more of a QLCS, fast-moving skinny squall line with embedded circulations by that time. But definitely an uptrend in the intensity of this event. The 3-kilometer NAM has a skinnier axis up tight on that surface low. That was one of the potential forecast failures that was mentioned by the Storm Prediction Center, is that a lot of the instability is further south to the south of the surface low, where the wind shear is less favorable, more straight line hodographs down toward the Kansas City area. Still could get an isolated tornado threat down there. You can see that the Storm Prediction Center has those tornado probabilities painted from Omaha through Des Moines, all the way up to La Crosse, Wisconsin, all the way down to Kansas City as well. Lower tornado probabilities down near Kansas City, as more straight line hodographs will be prevalent down there. But if you get a dominant supercell, even down into northern Missouri, that turns sufficiently right, that could also develop a tornado threat. Here is the main trough ejection. And always focus on the shape of these troughs. You want to try to recognize consistent shapes of ejecting troughs that correlate to a higher end severe weather or tornado events. And notice how that trough lifting up toward the Corn Belt, passing right over Omaha, relatively vertically stacked surface low up to the 850 low, up to 500 millibars. That's a very mature trough that intensified upon ejection from the Mountain West. Already a potent surface low. That was the previous GFS solution that showed that about 48 to 72 hours ago. The NAM, the European model, the short-range cams have all gravitated toward that stronger surface low, which is what you'd expect with a potent shortwave with a negative tilt. Notice how it has that negative tilt. The trough axis tilts northwest with latitude. That is a classic case for a rapidly deepening surface low, and that's exactly what we get with that 993, 994 type of a surface low. I want to break down the convective evolution with the 6ZHRRR, and then realizing that the 12ZHRRR is on its way out. We'll look at that as well and compare. This lead wave of precipitation moves through the target area, might have a little bit of an impact, could make that instability axis a little bit more skinny, but the HRRR rapidly destabilizes the atmosphere behind this band of convection. You could also see quite a bit of precipitation to the north of the warm front, which could encourage the surface low to kind of track right along the southern gradient of that precipitation shield. That should be where that warm front will set up. Quite a bit of precipitation to the north of that warm front will probably impede its advance all the way up to the Minnesota border. And then you start to get the development of surface-based storms. Northeastern Nebraska, back toward the Omaha area. This cluster is going to be particularly concerning just to the north of Omaha. This is at 20Z. That's about 2 p.m. Central Standard Time, and those storms are going to develop very close to the Omaha area. That's also just ahead of that surface low, down to 993 millibars in southeastern Nebraska. So I do think that these early storms that go up with these surface easterlies on the northeastern lobe of that surface low are going to have a tornado threat right out of the gate, right after they develop. It's right on the nose of that low-level jet. Dew points, they're going to be in the 50s. But look at that little zone of higher dew points wrapping around the surface low. HRRR is even painting some near 60 dew points near the Omaha area by 20Z. That is nasty for this time of year, early March. We're talking about a March 5th type of an event here across the Omaha area. The storms will initiate right off this arc. This is a dry line. Dew points dropping down into the teens back behind it. Upper 50s out ahead, even near 60 wrapping around. This nose here, right at the dry line, this bulge is going to be a supercell factory initiating storms along that arc of supercells, and it is a very favorable environment for tornado potential. Look at that nasty supercell that sets up just to the north of Council Bluff, north of Omaha, southeast of Sioux City. Probably a belt of snow across southeastern South Dakota there as well. Look at that. Pretty heavy snow on the northwest side of this potent surface low, closer to the cold pocket of air aloft, a deformation zone that is setting up. And then you're going to have a tornadic supercells, an arc forming here by 3 p.m. Central Standard Time, just to the north of Omaha. These could be tornado producers as well, just to the north of the surface low. But you'll want to target just on that northeastern quadrant. Looks like that's going to be the dominant storm moving off to the northeast, just on the northeastern quadrant of that 993 low. Some evidence that storms will start to build down the front as well. Looks like it's going to be east of Kansas City to me, the arc. Even though Kansas City's right on the edge of that 2%. There you can see that surface trough axis. There's your arc of supercells that's approaching Des Moines by about 5 p.m. Central Standard Time. And it builds all the way down into northern Missouri. Those will probably have tornado potential as well. Back into northern Missouri, quite a bit of wind shear by 5 p.m., even down into southern Iowa and northern Missouri. Further down the arc, a little bit further removed from that surface low, still very favorable hodographs for that tornado potential. Let me get my head out of here so that we can better see that hodograph. So that's a pretty textbook hodograph for a tornado threat. You've got your low-level jet, south-southwest surface wind in excess of 50 knots, or south-southwest 1 kilometer wind in excess of 50 knots. Your surface wind in the teens, 17, 18 knots out of the due south. Even a little bit of backing down into far northern Missouri. Quite a bit of directional shear in the low level. So this is definitely a hodograph that favors tornado potential, even a strong tornado or two. You've got in excess of 350, 0 to 1 kilometer shear. Cape about 500. Might even verify a little bit stronger than that. That arc of shear goes all the way up to the warm front that's pivoting up through northern Iowa. Strong low-level jet as well. Look at that. Central southern Iowa. Southwesterly low-level jet with those surface winds. South-southeast. Even a little bit of some backing, especially up near that surface low. There's the 850 low, centered right over that Missouri River across western Iowa. We'll look at surface-based cape and then the low-level cape, but maximize right up tight against that surface low, even at 23Z, as that arc is starting to overspread and have no problem moving off that boundary. Let's look at how some of these hodographs look early on as well. A little bit skinnier to the east of that surface low, but look at this dry pocket of air coming in aloft, helping to steepen those lapse rates. Very fat cape there. The dashed line is your partial ascent, an infinitesimal hot air balloon lifting up. As long as it's to the right of the red line, which is temperature, it's warmer than temperature and continues to rise all the way up to the equilibrium level, which generally represents the top of these very tilted supercell storms. The dry air that comes in above 3 kilometers is key to causing these lapse rates aloft to be steeper. And you've got close to 2,000 cape up there, 200 0 to 1 kilometer shear. Stronger shear builds down closer to the Missouri-Iowa border late. And still some sufficient cape to get vigorous updrafts right on that little elbow. You want to look for the elbows within this arc, this arcing dry line bulge. That's usually the most efficient initiators of supercell storms. You've got a bulge down here near the Iowa-Missouri border. You've got a bulge up near the I-80 corridor as well. See what the 12Z is showing. 12Z is showing a similar evolution of that cape axis. And boy, it looks like an early event just to the north of Omaha by about 3 p.m. Looks quite favorable. Even though you have straight line hodographs right there, the hodographs don't quite get as favorable until that arc moves off to the east, but an abundance of cape to the north of that surface low. I'd expect a little bit more directional shear to the northeast of that low. We may just not be sampling it with that particular sounding. We look at one just to the north of the surface low, slightly better hodographs there as well, but still it has a tendency to veer a little bit at the low levels. So it is a little bit west of the shear. You can see that the greater co-location of your 0 to 1 kilometer storm relative helicity and the surface-based cape is nosing right up to the I-80 corridor just to the east of Omaha. Then it really blows up. So it looks like Omaha looks like a pretty ideal target just to the east of there on I-80. There you can see those hodographs really start to elongate. Still a ton of cape as well. Temperatures rocket into the mid-60s. Dew points into the upper 50s as well. So quite a favorable environment thermodynamically for a tornado threat. That's a very favorable hodograph right there. And that 1 kilometer wind is going to nose up to 50 knots as that arc pushes off to the east. I want you to notice the directional shear as well. You've got a south-southeasterly surface wind at about 17 knots. That surface wind being over in this northwestern quadrant is key. That indicates some backing at the surface. But then your 1 kilometer wind south-southwest. So you do have about 10, 15 degrees of directional change between the surface and the 1 kilometer wind. And then your upper level wind sufficiently veered to force almost a due southwest to northeast storm motion at about 40 knots. So they will be moving relatively fast. Pretty steep low level lapse rates as well because of this dry pocket of air that comes in aloft. And that's going to act to clear out the cloud cover and rapidly enhance that instability behind some of those lead bands of showers and thunderstorms. So there's our arc. It's going to be, probably want to target the I-80 corridor on the northern portion of this arc, and you can always drop south toward the Missouri, north-central Missouri border with time. Just blossoms there at 6 p.m. The nose of that going all the way up to the I-80 corridor. Definitely going to be an arc of supercells that outruns the initiating dry line boundary. These supercells will probably be on the northeast side of this instability axis by 0Z. Certainly with that tornado potential as it pushes off to the east. Probably want to be on that storm across northwestern Iowa by this time, but certainly could build further south as well. The HRRR is pretty consistent with this zone just to the northeast of the surface low, having the most vigorous updrafts, the most likely supercell storms. And they lift off to the northeast, and you start to lose the daytime heating, which is going to be critical for this event. And you start to lose the identity of your convective line as you get after sunset by about 9 or 10 p.m. as it's starting to approach the Mississippi River. Might have one rogue supercell within this southern mode moving into northwestern Illinois late, 10 p.m. or so, 7, 10 p.m. or 8, 9, 10, 11 p.m. Lifting up toward the Wisconsin border there as well. Well, you get snow and icing. Minneapolis off to the north, and the wraparound with that 993 low moving through southeastern Minnesota. And there's actually 3 days of storm chasing in a row with this event. Looks like several inches of snow back on the northwest side, eastern South Dakota. Black Hills could get hammered as well. Southeastern Wyoming doesn't look like the huge upslope event that we thought. You're going to get these transient surface lows, transient ejections from Colorado. You really need a El Nino conditions to get those big stationary upslope events that will last for days, where you can get 30, 40 inches across the foothills of Colorado. That's definitely more of a split flow type of a pattern, an El Nino-like pattern with a lot of warm water in the subtropical and the northern Pacific. See what the new NAM has for snow out here. Kind of a spotty area of snow. It is early March. This is just how the snow maps look during spring. A little bit more spotty. Let me get rid of this so that you can see it. It's definitely going to be more of a far northeast Colorado event up towards Cheyenne. Nebraska Panhandle looks to be in that snow max. Could even get some double-digit totals out here, especially across the Nebraska Panhandle and maybe across east central South Dakota, west central Minnesota, as that surface low, 993 surface low, passes across southeastern Minnesota. Got to give the GFS love for nailing this setup 72 hours plus in advance. Definitely shows some greater upslope to the west of Cheyenne, out near Laramie. Chugwater, if you believe the GFS, could easily get in excess of a foot there across the higher terrain to the northwest of that surface low ejection. Just long enough snowfall duration, enough intensity out there too to generate some decent snow. And then the focus shifts toward Sunday night, where there'll be a severe weather event. Arklatex, portions of Arkansas. It's going to be a nocturnal event on Sunday night. Might even try to chase this as well, depending. We are going to have 3 days in a row of severe weather. But it looks like a Sunday night event that will evolve. Not sure if the timing is appropriate for that next blob that is going to be ejecting. That's the kicker system back behind the one that's going to lead to the severe weather on Saturday across Iowa. This is going to be Sunday into Monday's event. Definitely a muddier trough ejection than the earlier models were showing, but I still think there's going to be severe weather, even across portions of the Mid-South on Monday afternoon as well. But it looks to me like the Iowa event is going to be the more substantial event of the two. But I do think Monday afternoon across portions of Mississippi could also have that tornado threat. Decent hodographs, warm temperatures, 76, upper 70s temperatures, dew points into the upper 60s, so a very moist environment down there across Mississippi once again. This will be Monday, so it's going to be a Sunday night event. Arklatex, portions of Arkansas, and then Monday afternoon, peak heating's going to ramp up once again. An abundance of CAPE. The NAM is showing close to 2,000 CAPE, about 200 0 to 1 kilometer shear, with more directional shear. Low levels due south at the very surface. Southwesterly low-level jet near 40 knots. That's expected with this more shearing out trough ejection. See how you kind of have this veered low-level jet, more of a southwest to northeast oriented low-level jet. You have more instability, but you're probably going to require pretty hardcore right mover to realize that tornado threat. But Sunday night, you have a more backed low-level jet across East Texas up into the Arklatex. Stronger low-level jet, the nose of that low-level jet all the way up to St. Louis. And even a little pop of instability goes up into southeastern Missouri with a warm front and that surface low moving up through the Ozarks into southern Missouri. There's that surface low, a weaker surface low with a front coming back behind it, surging down through the southern plains. Slightly more of a subtle surface low approaching the St. Louis area by this time. That kicker system just isn't as robust because of the stronger initial system for Saturday heading up into Iowa. But I can see right along this warm front and a little bit to the south over southeastern Missouri. Sunday night, maybe closer to midnight, could be an interesting target. 2 points, a rocket up into the low to mid 60s. Rapid moisture advection happening. Pretty strong low-level jet as well. Pushing 60 knots across southeastern Missouri. And that strong low-level jet extends south all the way into central Arkansas. A ribbon all the way down into East Texas as well. The NAM model does show vigorous convection up tight to that surface low along the front. Not as much with the regular NAM showing, potentially showing the hint at a prefrontal confluence line that could be an initiator of storms. Not really showing up as well in the surface field, but it's there. Decent pocket of energy helicity index across southeastern Missouri. A large Hodograph. A little subtle elevated mix layer as well, just above 3 kilometers. So more of a classic nocturnal event Sunday night, southeastern Missouri, and then spreading toward Mississippi, Alabama on Monday with a lower end tornado threat as that low-level jet is a lot more veered. See how it's ejecting off to the northeast? That's because your upper level system is shearing out over top. You don't have a bulbous bowling ball-like of a trough ejection into that warm sector across the Mid-South. So that's what we're dealing with, everybody. We do have the Storm Prediction Center that has painted a large portion of Iowa with tornado probabilities, except for the very far northwest corner of Iowa, where you could even get into some wintry precipitation, including southeastern South Dakota. Tornado probabilities all the way back to Omaha. I do agree with that. As well down into northern Missouri. Does look like that arc of severe weather is probably going to mature just to the east of Kansas City, but it is possible that it could initiate up and down the Missouri River from Omaha to the north of Omaha all the way down to Kansas City and then push off to the east. Timing on initiation is still a little bit up for questioning. So thank you, everybody, for tuning in to this morning weather briefing. I am going to be doing a live Q&A this evening for Facebook supporters exclusively. That's going to be at 7 p.m. Central Time, 8 p.m. Eastern Time. I'll post another announcement on that later on today, but we're going to do a deeper dive into the forecast models to see exactly where that arc of supercells is going to eject. Where exactly am I going to target? I think I'm going to fly into this one just because driving... I just got my legs loosened up from that recent trip with the ice storm, the dual storm chases across the Mid-South, heading all the way back to Oklahoma, and then digging up that quartz outside of Hot Springs. Just finally got my legs loosened up, able to run double-digit runs again, and definitely going to be flying into this target on Iowa, and then I'm going to have to figure out the next few days. Do I skip Sunday night and then position for Monday? Or just do a one-and-done chase up into Iowa. Definitely going to be more of a complicated logistics chase, however. So, surface low track looks to be the target with this one. Look at that. Powerful surface low there. 993, 994 ejector. That is definitely a deep surface low ejection, not that flat trough that was being depicted by the European model and the NAM models leading up to this event. Negatively tilted lobe to that short wave definitely is doing work to rapidly deepen that surface low. I'm going to be activating Storm Chase mode on Saturday, so definitely stay tuned. Getting the band back together out there. We'll be deploying gravitron sensors in the path of this storm and more using flex tape products. So thank you everybody for tuning into this weather report. Never stop chasing.